Hi everybody, this is a video on congruence in right triangles where you will learn to use and apply a new theorem, the hypotenuse-leg theorem, to prove congruence in right triangles. Okay, so the last video we were talking about isosceles and equilateral triangles and some special theorems and properties with those. Today it's right triangles. Let's just make sure we understand what a right triangle is. It's a triangle that has one right angle. This is an important point. It's not a triangle with a 90-degree angle. You have to specifically state that it's a right angle, and that'll become important in proofs. It has a hypotenuse and two legs, as you know. The hypotenuse is always the side opposite the right angle, and the legs are the sides that include the right angle. All right. So the hypotenuse-leg theorem, what is it? And often we just call it the HL theorem. If the hypotenuse and leg of one right triangle are congruent to the hypotenuse and leg of another right triangle, then we know the triangles are congruent. So a longer way of stating that is just if I have these two triangles and they're both right, their two hypotenuses are congruent, their legs are congruent, then they're congruent. Now, if you look at this, you might get a little confused at first because this looks like side-side angle, doesn't it? Side-side angle, and we said side-side angle was not a valid congruence theorem, and it's not, unless you have a right triangle, and that's why this has a different name. It is not called side-side angle. It is called hypotenuse-leg because the only way side-side angle works is when you have right triangles, because then we don't have the hinge problem we were having with side-side angle. So you've got a side, and a right triangle. Then it works. Okay, so very important. In order to use HL theorem, there are three conditions that must be met every time. You must have proven specifically and explicitly that they are both right triangles. You must say that they have congruent hypotenuses, not equal, but congruent. And you must state that there is one pair of, once again, not equal, but congruent legs. And if you have all three of these criteria, then you can use HL. Okay, so let's look at some triangles and see if we can figure out if they're congruent or not and why. So here I have a side, an angle, and a side, an angle, and a side. Well, yes, they are definitely congruent by side, angle, side. But whoa, hold on, they're both right triangles, so I'd love to use my new theorem, HL. Well, there's a problem with that, right? HL had three conditions: right triangles, congruent legs, but also congruent hypotenuse, which I don't have here. So I cannot use HL. Don't jump to the conclusion that if it's a right triangle you can use HL. Not necessarily. Okay, let's look at this one. Okay, well this one I know using the reflexive property that this side is congruent to itself. So I've got a side, an angle, and a side, an angle, and a side. This is just like the last example. I can say yes by side, angle, side, but I can't use HL because I don't know anything about the hypotenuses. Okay, let's come over to this one. This side is congruent to itself. So, whoa, hold on. These are right triangles, condition 1. Legs are congruent, condition 2. Ooh, this side that's congruent to itself by the reflexive property, that's the hypotenuse of both of those triangles. So I met that criteria as well. So this time I can say yes by HL. If we come down to this theorem, this triangle here, we got a lot of ways we can prove congruence. These are definitely congruent. I can do side, side, side. I can do side, angle, side. Of course, these are all congruence theorems. And I can do, I can do HL because I've got right triangles. I've got right triangles. I've got two congruent legs, actually a bunch of congruent legs, and congruent hypotenuse. So I can also use HL here. All right, let's look at this one. All right, this is looking good. They're both right triangles. Check. Congruent hypotenuse. Check. Uh-oh. I haven't proven any legs are congruent. And there's no other congruence theorem I can think of to use here either. So no, these are not congruent. Now if we look at this triangle, I know this is congruent to itself by the reflexive property. I don't have anything about legs, so I can't use HL, but I do have angle, angle, side, angle, angle, side. So I'm going to say yes by angle, angle, side. Now, This is those same two triangles, kind of a similar situation. In the other case, it was the hypotenuses that were congruent. In this case, it's the legs. But we still have the same situation, which is angle, angle, side, angle, angle, side. So I know they're congruent. For some reason, the book wants to call out to you that specifically, if you've got a leg and an acute angle of one right triangle that are congruent to the corresponding leg and acute angle, and they're both right triangles, that they're congruent. But you know that anyway because of angle, angle, side. All right, so let's do a proof. Yay. We're going to use our new knowledge of a hypotenuse-leg theorem, and we're going to come up with a proof here. Okay, so I'm just going to write my statement here, my reason here. Okay, let's look at our givens and let's mark things up so we understand what we're dealing with so that we can devise a plan for this proof, not just start writing down statements. Okay, I'm first being told that BE bisects AD at C. That means this is acting as the bisector and AD is what is being bisected. This is very important. I'm not saying BC and CE are equal. I'm going to be saying that AC and CD are equal because this bisected it, meaning that this is equal to this, but it is stating nothing about how these two segments are related. Okay, so now I've marked that up. They already marked for me because they're perpendicular, they're meeting at a right angle. And let's see, and then we have, so that's handled this, and then we have AB congruent to DE, and that's already been marked up for us. Great. So now I have to come up with a plan I'm going to use. Now, we could use a plan of saying these two angles are congruent because they are vertical angles. And then we would have angle, angle, side, angle, 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 side. We would also, because saying these two are equal with bisecting, we could do side, angle, side. There's a lot of different ways we can do. But I have a new theorem I want to use, and it's the HL theorem. So that's going to be my plan. I have proven the hypotenuse congruent. I can prove them congruent, the legs congruent, that they're both right triangles, and I can use HL. So just to remind myself on this side, I'm going to talk about all my criteria I need to make sure I prove. I've got to prove congruent hypotenuses. I've got to prove congruent legs. And then I've got to prove that they are right triangles. I mean, they're right triangles. Okay, let's do it. Let's start with a given that'll give me the legs real quick. Let's do that AB is congruent to DE. They've already given me this, and the reason is a given. So now I have handled the leg portion of HL. Okay, next. Now, let's get the hypotenuses. So, bisecting means it divided AD into two equal parts. So that means that AC is equal to CD, and that's the definition of a bisector. Okay, but I know I need to show, and those are the hypotenuses, but I need to show them congruent, so let's just do this. Let's just say AC is congruent to CD, and that's by the definition of congruence. Okay, I've met my second criteria. All I need to do now is prove them both to be right triangles. Well, I know, and I'm going to cheat a little bit and put these two together. I know that angle B and angle E are right angles. And I know that because of the definition of perpendicular. They meet at right angles. Okay? And so I've stated that they are right angles. You might think, okay, I'm good. I've got two right triangles. I can go straight to HL. I can't. What I need to state next, and remember, I have to explicitly state that I have two right triangles. So now I could do this in 2 steps or in 1 step. I'll do it in 2. I'm going to say that triangle ABC is a right triangle, and that's because of the definition of a right triangle. And I can say that triangle DEC is a right triangle. And that, once again, is the definition of a right. Oh, triangle's not very good up there. A right triangle. All right. Whew, I met the third criteria. I've got the hypotenuses, the leg, and the right triangle. I can now state that triangle ABC is congruent to triangle DEC by the famous HL theorem. You can see QED. Remember when we did that way back when we were learning proofs? That's that Latin for I'm done. Okay, great. So see you guys.